Good morning. Welcome to this video lecture on torque equation of three-phase induction motor. Before learning about torque, we will just see what is torque. Here you find certain images, two images here. In the first image, you find a person trying to tighten a bolt. The force that is acting on the bolt is called as torque here. That is, the force, rotational force that is acting on the surface of an object, we call it as torque. So it is the force that is acting on the bolt, on the surface of the bolt, is the torque here. So if you want to calculate the value of torque, it is the force that is applied to the spanner handle into the distance between the bolt and the spanner handle. Right? That is the value of torque. Like in the third image, you find a person like opening a door. So the force that is acting on the hinges of the door is the value of torque here. So the value of torque here, the value of torque will be equal to the force that is applied to the door handle into the width of the door. If you take up an electrical machine, in the case of DC machine, in the DC motor, the developed torque will be proportional to the value of flux into armature current. The same thing when it is translated to AC motor, that is a three-phase induction motor. T is proportional to flux into rotor current here. Armature is the rotor part. So it is rotor current into power factor. So the power factor of the rotor circuit is essential. So T is proportional to phi into I2 into power factor. By applying Ohm's law to the rotor circuit, I2 can be calculated as rotor voltage at running condition divided by rotor impedance at running condition. Rotor voltage at running condition ER is equal to slip into rotor voltage at standstill condition. So I2 is equal to S into E2 divided by rotor impedance. Similarly, when you try to calculate power factor, it is R2 divided by rotor impedance at running condition. And flux is proportional to rotor voltage at standstill condition. So all the factors are dealing with the rotor circuit here. So T is proportional to S into E2 square into R2 divided by R2 square plus S into X2 the whole square. So when you draw the characteristic curve, normally for a DC motor we draw it as torque speed. Here it is torque slip. We can draw it as two different curves. The first one showing the impact of voltage, showing the impact of voltage variation. So we like in our torque equation, we have learned it as T is proportional to S into E2 square. So if you take up different values of voltage, here for example, if we assume three voltages, V1 greater than V2 greater than V3, for V1 we find the torque developed to be very high compared to the value of V3. Similarly for rotor resistance, if you consider here R2 being very low, all the three values of torque is same, but the condition at which it is achieved, or the value of slip at which maximum torque is achieved differs. So for lower value of rotor resistance, the slip is maximum slip that is achieved is very high, right? For medium value of resistance, the slip is like it is medium, right? For high value of torque, value of rotor resistance, the slip is at which the maximum value is attained is going to be right. It is going to be earlier the stage. So if you try to calculate the maximum torque value, right? Maximum torque value, again the condition, it depends upon the slip, and S is equal to R2 by X2 is the condition. And when you apply this condition to the torque equation, we get the value of maximum stress. Similarly, we can calculate the value of maximum starting torque also. So the condition for attaining the maximum starting torque is R2 to be equal to X2. When the rotor resistance is equal to the rotor reactance, maximum starting torque can be developed in the machine. Hope you would have understood the torque equation of three-phase induction motor, and you'll be able to pick up this assessment questions also. Happy learning. Thank you.